Hi to all, I hope you're all doing really well. In today's tutorial I would like to show you how I use the combination of softwares to be able to create a multicolor print like this. The particularity of this print is that it has multiple layers that are stacked both on top and on its underside. And to be honest, there were quite a bit of challenges to obtain this result. In this video I will cover how to model our design in FreeCAD, how we can use Inkscape graphics for text and other shapes to be later imported in FreeCAD and used as basis for extrusion. And then we will see how we can control our single extruder printer to create a multi-layered multicolor print. Before we start, it is useful to do a quick recap of the softwares used. And as for FreeCAD release, I'm using realthunder's link branch, and the latest release at the time of making this video is the 01.11. You will of course find all the links necessary in the video description. We will use the Cura slicer for slicing our design, and in order to be able to control our printer and achieve the multicolor layered print, we need to be able to communicate with the printer via USB, and for that we will use PrintRun. A really simple to use and straightforward software for directly communicating with your printer. For the SVG graphics we will use Inkscape, and if you like the way FreeCAD's interface is set it up, there is also a quick and simple tutorial that I made on my YouTube channel, and you will find the link in the video description for that also. Okay, so assuming that our desired result is this 3D printed keyring, let's take it step by step and see how we can achieve our goal. We start by firing up FreeCAD link branch and creating a new file. We will save this file as keyring, and as a first step we will switch to part design workbench, and we will create a new body. Right click on the body's name and we can rename it. I will call this body main body. Inside this main body container, let's create a new sketch. We will map it on the XY plane. Okay. And let's start by creating a rectangle. With the latest release of FreeCAD, we have some new options as well as some shortcut changes in the sketcher. I will choose a centered rectangle. Hitting the center origin of our sketch, I will create this rectangle, and you see that it is already constrained symmetric to the sketch origin. Select this edge here, and by pressing L on your keyboard we will give it a 60 millimeters length. Of course you can always use the constraint icons, and the tooltip will give you a hint about the new shortcuts. I want this edge here to be 20 millimeters, so I on the keyboard 20 millimeters length constraint. If we take a look at our original file, switch to top view, we have this opening here, and I will model that as well. So let's switch to a regular rectangle. We will draw a rectangle here, right click to dismiss the tool, select these two vertices and the x-axis of our sketch, S on your keyboard for a symmetry constraint. Now switch to construction geometry. I will create a rectangle, right click to dismiss the tool, select these two edges, E on the keyboard for a equality constraint, and I want this edge to be L for a length of 2.5 millimeters. Now what we will do is we will select this vertex and this vertex here, C on the keyboard for a coincident constraint, Ctrl Z because I didn't want that, So let's try again. I want this vertex here and this vertex here. C on the keyboard for a coincident constraint. And I want to do the same thing with these two vertices. C on the keyboard for a coincident constraint. Now we know that this edge here has a 15 millimeters dimension, and we can confirm that if we change to reference constraints, you can see here 15 millimeters. Let's switch back to normal constraints. I want this edge here to be 10 millimeters in length, so L on the keyboard, 10 millimeters. Now with our sketch fully constrained, we need to close the sketch and we will pad it for 5 millimeters. Okay. I will switch to shadow view. You can also do it from here. You can switch through the various display modes. Select our main body, Ctrl D on your keyboard to set a shape color. I want this shape to be something more dark, just to reflect a little bit the color of my black filament. We will close this task, and taking a look at our reference model, we can see that we have some fillets. So let's go ahead and model those. Select this edge here, and in LinkStage3 you can see how there is this really useful feature where the model becomes transparent and will permit us to select occluded edges or faces. This can be enabled from here, and choose selection on top if you want it, and this will help us select edges that are occluded by the model. So use Ctrl on your keyboard to select multiple edges, and we will use the fillet tool to do a 4 millimeters fillet. Hit OK. I think that I want these edges here also filleted. So we will create another fillet, and this time perhaps 2 millimeters will be okay. So 0 on your keyboard for a perspective view, and essentially with this we've quickly managed to model the base of our print. Okay, so at this point, looking at our example file, we see that we need to create the graphics for the text and the FreeCAD icon. To have maximum flexibility, we will use Inkscape for this. So let's get back to our file, and let's try to have a better idea of the space in millimeters that we have to place our graphics. I will create a new sketch only for reference on the XY plane. Okay, let's switch to wireframe view. I will create a construction rectangle. Let's select these two vertices and the y-axis and the x-axis of our sketch, as on the keyboard for a symmetry constraint. I want this edge here to be I on the keyboard 15 millimeters, so it will match with our hole, and I think that this edge here could be L on your keyboard 43 millimeters, and we're pretty much inside our print area. We need to keep in mind these dimensions, because the Inkscape file will use these dimensions for the page. So with these dimensions in mind, let's fire up Inkscape, and I will simply open the FreeCAD link branch icon. Let's click OK. And in order to have an easier life importing in FreeCAD, we need to tweak some document properties in Inkscape. If we remember well, the width of our document is 43 millimeters, and we need to change the unit here in millimeters. So width 43 and height 15 millimeters. Press 5 on your keyboard to see the whole document, and this way we make sure that we stay in the area that we have free for printing. Let's select our icon and because I want to preserve the aspect ratio, I will hit this lock icon, and I will make it a height of perhaps 12 millimeters. And of course we need to change the unit here as well in millimeters. Let's try again, 12 millimeters. Click the Align and Distribute icon. I will select the page as the relative reference, and I will center the icon on the page by clicking this, and I will also move it all the way to the left. Now we will create some text. With our text created, we need to be aware of the fact that FreeCAD will have difficulties importing SVG graphics that are not in a PAF format. So with this in mind, we will select our icon here, we will go to the PAF menu, and we will select Object to PAF. The same thing we will do with the text, so select the text and Object to PAF, and by realthunder PAF, Object to PAF. Now that we have our file ready for importing in FreeCAD, we will go to File, Save As. I will save this file as PAF graphics as SVG, and as file format plain SVG. And let's get back to FreeCAD. This sketch isn't necessary anymore, so we can clean our tree by deleting it. It was just a reference sketch. Now let's go to File, Import, and we will import our PAF graphics SVG. We will import as geometry, select, choose yes, hide for a second our main body, switch to top view by clicking 2 on your keyboard. One thing that I like to do is to group them under a new part, and this way you will see where the origin of this geometry is. So select all the paths that we have imported in FreeCAD by using Shift, and let's drag them inside our part. I will rename this part, and I will call it graphics. And let's start the process of transforming these paths into something usable for the part design to model geometry. Okay, so if we take a look at our example file here, we can see that the graphics are made by pads that take as a reference some shape binders. This just to make you understand what we are trying to do here. Back into our working file, we need to clean this geometry a bit, so I will select some of the paths that I don't need and delete them. This one also. Hit cancel on your keyboard. If you hover with the mouse over the various bits and pieces in the tree view, you have a highlight in the 3D view, so you can see what's going on. Also, because I've tried this previously, I know that this path here will be a problem, and I'm deleting it, so bear with me. And now our goal is to use these graphics as basis for pads. To do this, we will use a really cool feature of the green SubShapeBinder, and that is the fact that it will try to detect closed areas and make a face if possible. Another thing to bear in mind is that at the moment we want to create our SubShapeBinders outside of these two containers that we already have. So let's click on the main body, and we will toggle the active body so it is not active anymore, and you can see that the highlight has disappeared. Also, we will toggle the active part. So let's start this process with the path for this F here. So let's find it in the tree, select this path and hit the green SubShapeBinder. You can see that it has created the SubShapeBinder in the main branch of our tree. I will rename it, so F shape, and we will slowly do the same with the rest of the graphics. If we take a look at our gear here, we can see that we have an outside outline but also the inside. If we select only the outside, the inside will the green SubShapeBinder will create a unique face. So if we select the outside path and the inside one, the SubShapeBinder will be smart enough to leave the hole here free. So let's try it and rename our new SubShapeBinder, and I will rename it as Gear Shape. Let's do the same with this arrow here, rename Arrow Shape. And now we need to move on to the text. So select the first path of the link branch text and try to find the path that represents the H. Hold Shift, select everything and hit the SubShapeBinder. Let's rename this as link branch, and we will do the same with by realthunder. So let's try to find the first element, hold Shift, select the last one and create a new SubShapeBinder. Rename it, and this way we have created SubShapeBinders for all of our graphics. These SubShapeBinders can now be used to create pads or pockets in our geometry. Let's hide this. And one thing important when you create SubShapeBinders, you need to make sure that the make face property is set to true in order to have the face created when the ShapeBinder detects a closed area. Now, another important property of this SubShapeBinder is called the bind mode. By default, the bind mode of the SubShapeBinders is set to synchronized. It is really useful to read the tooltip for this property, because it will give you some really interesting insights in how SubShapeBinders work. For our model here, we need to select to set the bind mode to detached, and you can see that the SubShapeBinder icon has changed. What does this mean? This means that now the SubShapeBinder won't follow any changes made to the graphics anymore, so it is like a frozen in time geometry at this stage. But also this will permit us to place the SubShapeBinders in a new body and move them freely in the 3D space. If this property is set it up to synchronize, the SubShapeBinder was designed to stay in place of where was originally created and to follow the geometry of the binded object, and that is useful for top-down modeling. Again, for our intent here, we need to have them detached. Okay, so now with our graphics prepared and ready for modeling, we will create a new body. Let's rename it as perhaps Printed Graphics, and selecting all of our SubShapeBinders, we will drag them inside our newly created container. We will select our SubShapeBinders because we want our extrusion to be red. Hit Ctrl D on your keyboard and we will set the shape color to something like this, a red color. Now, this hasn't done anything special, when only changed the color of the faces on the binders. And now if we make our extrusion, you can see that the F is now red. I want this extrusion to be 2 mm in height. Hit OK. Let's switch to shadow mode, and we will do the same with all the other geometry that we have here. I will pad the gear for 1.5 mm, okay, and the arrow we will pad it perhaps for 2 mm also. And with this we have created our graphics to be placed on top of the main body. What we need to do is to transform our shape. So let's switch to front view, hit OK, select the printed graphics, go into data of the properties view and expand the placement entry position. We want our body to be in the Z direction at 5 mm, in the Y direction at 7.5 mm, because This way it will be centered with our main body. So select it again, and X position we can make it something like -16 millimeters. Okay, so now if we take a look at our example file, we need to create this outer perimeter extrusion. So let's get back to our file. With our printed graphics body active, we will create a new sketch. We will map it on the XY plane, hit OK. We need to import some external geometry, and I will import this arc here and this arc here. Let's close our sketch, switch back to shadow mode. I will pad my sketch for 2.2 millimeters. Hit OK, and one thing that I would like to add is a fillet on this edge, and hit OK. Okay, so we have our top body print modeled, and we need a way of creating the bottom one without going through all the modeling. For this, we will take advantage of the link functionality in FreeCAD, and with this technique, the advantage is that whatever changes that we made to our printed graphics body will reflect them for the underside. So select the printed graphics, hit the make link icon, and we have a link of the printed graphics. Right click on the entry in the tree view, click transform, and we will rotate it by 180 degrees. Hit OK. If we select our link in the property or combo view, we will tweak its position, and I want it to be at 0 millimeters height, at -7.5 millimeters on the y-axis and -16 millimeters on the x-axis. And as you can see, we have perfectly placed our new body where it needs to be. Okay, so this pretty much wraps up almost all of the modeling part of our tutorial. It is now time to get to our printer. So we will start with the easy part of printing with the black filament, the main body. So we need to select our main body container in the tree view. We will go to File, Export. We will choose STL mesh as file type, and we will name it main body STL. Let's save this export to a known location, and now it is time to fire up Cura. And then let's open our file. So File, Open Files. If we select our mesh, one important thing that we need to keep an eye off is the positioning, which in this case is at the origin. As printing profile, I have a generic ABS printing profile, and because I know that this particular type of filament will shrink a lot, I usually scale my mesh by 2% in uniform scaling mode. Some other relevant settings in my case is the layer height at 0.15 millimeters, and I have a 5% infill density, and skirt as build plate adhesion, as this will purge the nozzle before starting the main print. Let's slice it and save to disk in order to send it to the printer, and we are finally ready to print our first component. Now that our first component is printed, we need to get a bit intimate and understand a bit more how our printer works. So our printer is controlled by Gcode, and Gcode is the basic programming language used for almost all CNC machines, including 3D printers, routers, and laser engravers. It instructs the machine on how to move, heat, and perform other actions. Most printers have a way of communicating with them via USB or Wi-Fi connection, and in my case I'm using a USB connection via a application called PrintRun. But of course you can use whatever application is provided with your specific printer. So getting back to our design, we can see that we need to print our red graphics on top of our main body. And here rises the first problem that we need to overcome. When we will slice this geometry in Cura slicer, the slicer will include in our Gcode file a routine for homing all axes. The problem is that we need to print the graphics offsetted from the print bed, and for that we need to eliminate the z-axis homing routine. Before we start, let's take a brief look at the G-codes that we might use for controlling our printer. The first one is the G0 and G1 G-codes. So G0 is used for rapid motions as fast as our machine will go. It is used to move the cutter or the extruder through air to the next place that will be cutting or will be printing. Instead, the G1 code will feed the motion slower in a controlled manner. The G90 and G91 are used to switch from absolute coordinates to relative coordinates. So G90 is switched to absolute coordinates, and this will instruct the machine to use the absolute coordinates of the machine, while the G91 command will instruct the machine to move relative to its last position. Okay, so now just as an example, let's try to issue some commands to our printer. It is important to note that while issuing commands to our printer, manual commands to our printer, it is really easy to crash the extruder into the workpiece, so we need to take some precautions. First of all, I will move the extruder up for 20 millimeters just to be on the safe side. So I will issue a G90 command, so the machine is in absolute mode. G0 for a rapid movement, and I want the Z position to go to the 30 millimeters mark. Now that I'm sure that the extruder won't crash into my print, I will home my y-axis. And here comes another command that we will need to learn, and this is the G28 command. This command is used for the homing routine. So if we do a G28 x-axis and G28 y-axis, the machine will be homed in the X and Y direction, and this way we've issued our first commands to the printer. Now that we are able to control our printer, let's take a look at the G92 command, which will be really useful in what we want to achieve. The G92 command on a 3D printer, it specifies the current location of the nozzle. Telling the printer where the nozzle is located may seem unintuitive, but in fact this command can be super helpful, especially when it comes to setting offsets. So as an example, if we switch the coordinate system of our machine to G91, so a relative one to the current position, we can issue a G0 Z minus 20 millimeters command, and we can see that the extruder will move 20 millimeters down from the current position. If now we issue a G92 command, Z0, this will instruct the machine that the current position of the extruder is actually the Z0 position. And this is essentially everything we need to print with an offset from the plate, but with the benefit of understanding how things work. Now let's get back to our file. I want to export the printed graphics, and I will select it. Let's go to File, Export, and we will call this file as Printed Graphics. Let's switch to Cura Slicer, and I will import my printed graphics STL file. Let's select it and make sure that it is always in the 0 position, centered on the plate. Now in Cura we need to change some slicer settings, and setting that we need to change is the build plate adhesion, and we will change it to none because it will be essentially printed in the air. Let's slice our mesh. We will save it to disk, and we will open the Gcode file with a text editor. Now what we need to understand is that Cura Slicer will rightfully introduce a homing routine for all axes, but in our case we need to avoid the homing of the z-axis because it will crash with our previously printed object. If you remember, the command for the homing routine is G28, and if we look at the beginning of our file on line 24, we have a G28Z0, and this is the homing routine for the z-axis. We need to get rid of this line of code and leave only the G28 X and Y homing routines. We eliminate the Z homing routine because we will manually set Z height for the extruder. So delete this line. Let's save our file and we will send it to the printer. It is now time for a filament change. Okay, so with our filament changed, let's move the plate to a safe position and purge the extruder until the red color comes out. And now we need to instruct our printer where the Z0 position is on top of our previously extruded component. We will slowly lower the extruder, taking great care of not bumping into our print. When we are really close, put a piece of paper on top of your print and slowly lower the extruder until it is in contact with the paper. At this point, we need to instruct the printer that the extruder is at Z0 position. So we will send a G92 Z0 to the printer, and we can load the printed graphics Gcode file and send it to the printer. Bear in mind that this file, if we take a look again at it, it has a routine for homing the X and Y axis, but we removed the Z axis homing because we've manually set it the Z offset by using the G92 command. So let's try and print it and see how it will end. So we have our second step of our print completed successfully. We need now to print the bottom side of our keyring. In order to do this, we will need to turn around our current print on the printing plate and print the underside. But in order to have a correct positioning of the geometry, we will create a jig around the keyring. Let's create another body. Let's rename this body as jig. We will create a sketch on the XY plane. And let's import some geometry from here. So we will use the import external geometry. I want to import this and this one. I will create a rectangle. with our sketch created. Let's re-show the geometry. I will pad the sketch for 5 millimeters. It's okay. So let's quickly chamfer some edges here for 2 millimeters or perhaps even 3. Hit OK. Let's create another sketch, always on the XY plane. Once modeled, we need to select our jig. We will export it as jig. Open it in Cura, slice it and print it on the back. Perfect. With this step achieved, we have now our jig in place and printed. We have placed the keyring already in there, and we have to go through the same drill of homing the X and Y axis and setting the Z height in order to print our graphics on top of the keyring. So we will do just that. We will now home the X axis. I will home the Y axis also. We will use the same technique with the paper and slowly lower the Z axis until it is in contact with the print. Once we are happy with our positioning, we will need to set the zero height for the Z axis. So again, we will issue a G92 Z0 command to the printer. Now that we have our printer nicely set it up with our X and Y axis homed and the Z position manually set, I will again open the graphics Gcode file and I will send it to the printer. Okay, so hoping that this tutorial was useful for learning how to model and to print a multicolor object using FreeCAD. I thank you for staying till the end. If you appreciate my work, please support me on my Patreon page. You can find the link in the video description. Thank you, and I'll see you in the next one.